Welcome to the Professor's DuBois channel. This is Professor Corey, and this video is a mini lecture based on our second lecture covering material from Chapter 1. Disclaimer: this is in no way equivalent to our actual lecture where we discuss and practice the material in much more detail. Our second lecture began with the metric units. We use the metric system in chemistry, so you'll have to become familiar with the units. It is also very important to include units whenever you record a number. These are a few of the ones that we use frequently. Derived units are a combination of two or more units. Density units are often given as grams per milliliter. This is a derived unit composed of two units, grams and milliliters. Some derived units are in disguise and are represented with a single letter. The joule is an example, represented by a capital J. This does not look like a derived unit, but joules are actually kilograms times meters squared per second squared. Careful inspection of units can often help you solve a problem. In this problem, the answer has units of grams divided by milliliters. So I can take the number of grams and divide by the number of milliliters and get the answer without putting a whole lot of time into reading the question. Very large and very small numbers are more easily represented using scientific notation. See our video on scientific notation if you need some help with this. You will have to be able to do calculations using scientific notation, and different brands of calculators vary in the approach. You will need to be able to do this on your calculator, so try the multiplication given, and if you cannot get the correct answer, see us or one of our TAs for help. There are 3 units of temperature commonly used in chemistry. For our exams, we will only use Celsius and Kelvin. Be able to convert from one to the other. 0 Kelvin is absolute zero. This is the lowest temperature can go. If you calculate a result that is negative in Kelvin units, you have made a mistake. Your homework in MindTap will include some conversions with the Fahrenheit scale. There are multiple methods for counting significant figures. We prefer the Atlantic-Pacific method. See our video on counting significant figures if you're not able to count them correctly. Whenever we make a measurement, the last digit is always estimated. This volume could be reported as 21.6 milliliters. I estimated the 6. You may have reported it at 21.7. This measurement has 3 significant figures. When you perform calculations, you will have to report answers to the correct number of significant figures. When multiplying or dividing, you will round your final answer to the lowest amount of significant figures in the measured data. Addition and subtraction rules are different. Here you will count decimal places of your measured values and round your final answer to the least number of decimal places in your measurements. Some numbers in the question may not be measurements, and these are not considered for significant figures. Lastly, do not round until you get your final result. Then use the measured data in the question to determine the number of significant figures and round accordingly. Thanks for watching. Please give this video a thumbs up and subscribe if you would like to see more mini lectures on the Professor's DuBois channel.